Okay, I thought I would do this little video for the essentials in chapter 2, and hopefully you all received my email and got a chance to check it out if you thought that it would be useful. So chapter 2 is focused on the chemical and physical properties of water, and some of the physical properties you need to be aware of is the fact that water is tetrahedrally coordinated, has an unshared pair of electrons on the oxygen, which gives it a partial negative charge on one apex, and at the base of this tetrahedron is a partial positive charge contributed by the bonded hydrogens. And this gives water its polar quality, making it very useful as a solvent, because it will essentially solvate or hydrate. Okay, solvate would be used to refer to the suspension of solutes in an aqueous solution, and hydrate usually refers to that aqueous solution as water. And also the fact that there are charges makes water, or gives water the ability to solubilize ionic solutes. And so we want to make sure that you understand those properties of water. As ice, water can form these crystals, these crystalline structures, as water orders itself with other water molecules in a hydrogen bonded network. Okay, we have the covalently bonded hydrogens in a hydrogen bond with the oxygen. And this can form a nice little network between the water, the oxygen, and the hydrogen. So this hydrogen bond is very abundant and can form these little crystalline structures in ice. However, liquid water is more irregular, and the hydrogen bonding can occur, but it's more or less irregular in terms of the position of the tetrahedral structures in the aqueous solution, and the position of the hydrogen bonds. It could be different positions, so it's less regular. But this facilitates the movement of the movement of electrons through water. They can jump from one molecule to the next, and this jumping is why electricity can travel through water. So this hydrogen bonding and the ionic bonding associated with the charges contribute to what's called the hydrophobic effect, and that is the free energy associated with water trying to disorder itself in a volume will drive a hydrophobic molecule to aggregate into an aggregate, and this is driven by the fact that water, being forced to order itself around this hydrophobic solute, will tend to drive this aggregation. So this is some of the other properties of water. Also, we need to know the distinction between diffusion and osmosis. Okay, you know that's the movement of water from an area of high concentration to low concentration. And osmotic pressure is a measure of the pressure that water exerts on a surface when it tries to move from high to low. And of course, as solutes move from high to low, this is referred to as diffusion. And that is a property, of course, that occurs in an aqueous solution, whether it's water or some other aqueous solution. So those are the physical properties of water. Chemically, you need to remember that water ionizes the hydroxide ion and the hydrogen ion, which we tend to represent in this way, but really exists in what's called a hydronium. And so the ionization of water allows one to determine a dissociation constant for that water, which is equivalent to the concentration of products over the reactants. And water is very concentrated, 55 molar, so it essentially is 1 in biological systems. So we use a convention which we refer to as pH, which is a negative log of the hydrogen ion concentration, and that convention is scaled from 0 to 14. Of course, 7 being a neutral solution, 14 being basic, and of course 0 being acidic. And so this convention now is used in determining the hydrogen ion concentration in a solution. Now in biological solutions, we need to maintain a pH which is about neutral, about 7.4. And what we need to do that with is a buffer, because cells contain acidic and basic acidic groups, amino acids in particular, basic groups, ammonia, byproducts that contribute to the solution and could cause the pH of 7 to go up or down when these cells die and release their contents. So we need a system in which, well, there is a system to take care of this dramatic change that could occur in a solution.